Okay, so today we're talking about the post-lab to the toy car. So here's a set of data that I made up, very similar to data that your group may have taken during the lab. In this particular data set, we have the slope is 38 centimeters over seconds, and the y-intercept is 20 centimeters. So if we wanted to write a mathematical equation, we would have position is equal to 38 centimeters over seconds times time plus 200 centimeters. Okay, so that's a skill that we used back in Unit 1, writing the mathematical equation using y equals mx plus b form, where we have y is the title of the y-axis, x is the title of the x-axis, the slope is the slope, 38 centimeters over seconds, and the y-intercept is here as 200 centimeters. Now, we can get an idea of what the slope means by using a for every sentence. We have for every 38 centimeters, there is 1 second. Or conversely, you can say for every 1 second, there is 38 centimeters. So the car moves 38 centimeters every 1 second forward. Now, what the y-intercept says is that at a time of 0, the car is at 200 centimeters. So what does that mean? It means that we can deduce that the slope is a new word for us. It's the velocity. And the y-intercept is the initial position. Now, we have an idea of what this initial position means. It just means where the car is at the time of 0, so where it starts. But what does velocity mean? Velocity tells us how fast and in which direction. Okay, so one thing that we talked about in our post-lab was that velocity can actually have a positive slope or a negative slope if it goes downwards. Okay, so ask yourself, what does it mean if we had a negative slope? Let's say we had a car moving with a slope like this, 38 centimeters per second, and we had another car that moved 38 centimeters per second, but with a negative sign. What that tells us is that for every 1 second, the car moves backwards 38 centimeters. Okay, so it is possible to have a negative velocity, and all that means is that your car moves backwards. And what a graph would look like would be a graph that looks like it has a negative slope. And I hope at this point you can also deduce what a position versus time graph would look like for a car that is not moving. I'll let you figure that one out. Okay, so what we have here is a general equation, and what that means, how that's different from a mathematical equation, is that it works for every situation so far. Okay, it's not specific to a car with 38 centimeters per second as a velocity, and it's not specific to a car that has an initial position of 200 centimeters. It works for every toy car. So we've got the x tells us the position at time t. The velocity is the slope here, how fast it's going. And we have x naught. Okay, that's a subscript of 0. I say x naught as the initial position. So moving forward, a lot of the math problems that we'll be doing in this class, or rather in this unit, is going to involve just manipulating and using this equation. All right, so at this point we want to ask, what if we graph the velocities at each second? So what if we made a velocity time graph? What would that look like? Well, let's take a look. We've got a position versus time graph with a positive slope of 38 centimeters over seconds. Okay, so this is a straight line. Everywhere on the straight line, the slope is the same. So we've got a slope of 38 centimeters per second. We want to ask ourselves, what is the slope at 0 seconds? And again, since this is a straight line with the same slope everywhere, we know that at 0 seconds, the velocity is going to be 38 centimeters per second. Furthermore, we can say at 1 second, it's going to be 38 centimeters per second. At 2, 38 centimeters per second. At 3 seconds, 38 centimeters per second, and so on. So what we'll actually see is a horizontal line. So the velocity is constantly 38 centimeters per second. And here we have it. The title of the unit is the constant velocity unit. All right, so let's get into the nuances of the velocity versus time graphs. So first off, we've got a horizontal line, and let's say that it hits the y-axis here at, I don't know, 2 meters per second. So we know that the y-intercept gives us the velocity. It's going to be the constant velocity of 2 meters per second right here. Okay, and now this is the first time of the year where we can actually talk about the area. And what I mean by the area is this region of the graph that's caught between the velocity line, our data, and the time axis. And a region is going to be caught up between an interval of time that we're referencing. So if I'm talking about between t equals 0 seconds and t equals 1 second, what's the area? Well, we just take 0 seconds here, 1 second here, and the space that's caught in between here is this rectangle. So what we would just find is that area is equal to base times height, which gives us 1 second times 2 meters per second. Multiplying this out real quick, we see that the seconds cancel out and we're left with 2 meters. Okay, so let's try that again. Maybe we can realize something. All right, so let's take a look at what happens if we do between t equals 0 seconds to t equals 2 seconds. How does the area change then? Well, we've got the 2 here. It gets cut off here. And we see our rectangle gets larger. And we know area is equal to base times height. And this time we've got a base of 2 seconds and a height of 2 meters per second. This gives us positive 4 meters. Okay? And as you can tell, if we were to do 0 seconds to 3 seconds, we would probably get positive 6 meters. So what this tells us is that for every 1 second, the object is moving forward 2 meters, which makes sense based on the fact that this velocity is 2 meters per second. Okay? The area is telling us how much the position is changing. So here we've got the takeaways from our velocity versus time graph discussion. We've got the y-intercept is the velocity, and this unit's a constant velocity. Area, we've got as a change in position, and in class we've talked about this as displacement. Change in position and displacement are synonyms, they mean the same thing. And the slope we will have to talk about later. Bye.